We've looked at solving systems of equations, setting them up, doing elimination, doing substitution. We looked at them graphically. But those are equations where there's going to be one solution. Now we're looking at inequalities. So it has to be less than something. It has to be greater than something. Maybe it could be equal to it. Now I have to figure out what the solution to that is. And no longer is it just going to be one specific value. I can't go through and list them out. Oh, this is my value. 5, 2 is the coordinate point that satisfies it. Because not only does 5, 2 work, 0, 0 might work. 1, 5 might work. -4, -8 might work. There may be an infinite number of solutions, and I can't just list those. So instead, what we're going to have to do is we're going to have to graph this, and we're going to have to show our solutions to an inequality or system of inequalities graphically. So I'm going to have to figure out which coordinate points are going to truly be answers to this problem. So I could try to determine, does 0, 0 work? Does 1, 2 work? Does 10, -5 work? All of those different situations as to what physically could be an answer. -4, 8. It doesn't matter. I can put an infinite number of possible points up there. So I have to figure out, well, which of these is going to be a solution? So I have to figure out where is this boundary marker as to where can it not be? And it could be everything but that. So sometimes you're going to want to look for the opposite effect of it. Well, where could it be, or where is the boundary piece to it? So what we're actually going to look at here is how do I physically solve a system of linear inequalities? The first thing that we're going to do, step 1, is we are going to first graph the boundary line. That's the equation part of it. So initially, going back to this problem, I'm going to graph that boundary line. I'm going to treat it as if it's an equation. So I'm starting by figuring out what is that boundary line. I did my y-intercept, and now I'm doing my slope, my 1/3. So from here now, I have to take into consideration it's just y is less than. It's not equal to. So I cannot draw a solid line. Solid line does not work because it is not every possible solution. Instead, it's all of the ones from there below it, directly below it. So to do that, we do a dotted line. So this says, here's my boundary line. It does not equal to it. The only way it would be equal to it is if there was a line underneath. So now we've drawn the boundary line. So that's step 1. Step 2, we have to shade. The shading represents the infinite number of points we could have. But the problem with that is the shading, you can't just assume, oh, it says it's less than it, it's going to be below. It says it's greater than it, it's going to be above. That'll be right sometimes, but not always. So in order to shade, you are going to have to pick a test point. You want to see, does that point actually work? My recommendation for a test point, 0, 0, 1, 0, or 0, 1. Those are the easiest test points we usually can pick to see if it works. Now, if that test point is on the boundary line, you cannot use it. Therefore, I gave you 3 points that do not lie on a straight line, and you can pick one of those 3. You can pick whatever one you really want. So in this case, I'm going to test the point 0, 0. I need to see, is 0, 0 a point? And by seeing if 0, 0 is a point, I plug it in. Is 0 less than 1/3 times 0 plus 4? My reasoning for picking 0, 0 is if there's a multiplier, it cancels it out. 1/3 times 0 is 0. So I need to know, is this a true statement? Is 0 less than 4? Yes. Which means 0, 0 has to be a point. And the only way 0, 0 can be a point is if I shade down. So from that boundary line, I shade down. That is the solution to that inequality. So that's how we graph the inequality situations. Now, if we're solving a system of linear inequalities, then not only do I have to keep going from here, I have to now do my next one. So if I have 2 of them, I have to graph both of them. But now, instead of shading right away, What instead I'm going to do is I'm going to draw these little arrows so I know what direction is included in this region, because in my steps, step number 3 is going to be look for the final shaded region. What includes all possible graphs? We call this the feasible region. One thing I'm going to add to this is in step 1, make sure you have a dotted line when it's less than or greater than, and make sure it's a solid line when it's less than or equal to. Equal means it also can be it, or greater than or equal to. So we're going to do a couple of quick graphs with this so you can kind of get the hang of what a feasible region is going to look like in the end. So I need to graph each of these 2 inequalities. I need to graph the first one. I need to graph the second one. These are both in standard form. I'm going to be graphing these using my intercepts. So take a moment, treat them as if they're equations. But keep in mind if it's a dotted line or a solid line. So go through each of them individually. I'll graph the first one, and then I'll pause it, and then I'll do the second one. So I found each of those intercepts. I found my 2 points. Now I'm going to connect the dots. This is just a greater than sign, so it's going to be dotted. Now I have to figure out which direction I'm going to shade based on my test point. The test point I'm going to use again is that 0, 0, because it does not fall on the line. So this becomes 0, because 3 times 0 is 0, plus 0 is 0 plus 0 greater than 12. So 0 greater than 12. No, that's a false statement. 0, 0 cannot be part of that graph. It's a false statement. Therefore, I'm going to have to shade above it. Okay, so that's how you use that test point. So now take a moment, graph the second one, I'll do the same thing. And since this one is greater than or equal to, this is going to be a solid line. And now I have to do its test point of 0, 0. Again, because it does not fall on the line. If it fell on the line, I'd have to pick something different. So 0 minus 0 greater than or equal to negative 8. So 0 greater than negative 8. Yes, it is. So I shade towards 0, 0, because 0, 0 has to be part of the solution. So I'm going to be shading down. So now I have all of my inequalities graphed. So what is the region that is included in both? It's this part right here. And that's my final answer. So you can have 2, you can have 3, you can have 4. However many you're going to have, it's just going to continue to restrict that region inside. So now I should be able to pull out any coordinate point off of the shaded region, such as 10, 1. That's just one specific point that I picked out. That's part of my shaded region. So I should be able to put 10, 1 in to both of these 2 equations, and it's going to be a true statement. So I can check it in the first one. So 30 plus 4, is that greater than, sorry, not equal to. Greater than 12? Yes. And then in the second one, 10 minus 4 times 1, so minus 4. Is that greater than or equal to negative 8? 6 is greater than negative 8, so that one works as well. Now, it's just one quick little check. It's not perfect, but at least it can randomly check things for you to see if you're on the right track. Next, we're going to graph this system of inequalities. So take a moment, please. Graph each of the individual lines. Draw your arrows. I will do both of these with my arrows drawn, and then I'll come back in and I'll talk about the shaded region. So the top one I did in red. And with that one, it's in slope-intercept form. So I graphed my y-intercept and my slope. It's greater than or equal to, which is a solid line. The second one is the dotted green. And that's because it was just less than. I did my intercepts for that, connected the dots. I did my test point of 0, 0 for both of them because neither of them go through 0, 0. When I look at both of them, they are both true statements, which is why they have to both shade towards the point 0, 0. So now I have to look at where is my overlap occurring at. In this case, this arrow is pointing downward. This arrow is pointing upward. Those are going towards the same direction. Therefore, my shaded region is within there. Last one. Now, the hard part about this is trying to figure out which direction does this go. The top inequality is the one that usually will mess folks up. Keep in mind, it's just an equation. Think about it as an x equals equation. X always has to equal 5. Now, again, it's not equal to, it's greater than it, but we initially have to do that boundary line. So, only place where x is going to equal 5 every single time is when I have a vertical line. It's greater than or equal to it, so it has to be a solid line. So find 5 and draw that line up. Okay, so that's usually the hardest part, is finding that boundary line for x equals or y equals equations. And then after that, so where would those values be greater than it or equal to it? Equal to is on the line, greater than is to the right. This is 6, this is 7, this is 8, etc. for your x values. And then you go through and you do your second one as intercepts, just like normal. So I graph both of the boundary points for that. It is greater than, so it's going to be a dotted line. Do your test point, 0, 0. Fortunately, I've picked most of these that do not need it. It's a false statement. 0 minus 0 is not greater than 6. So it has to shade away from 0, 0, which is to the right. So the parts that are going to be shading or agreeing in the same direction would be this region here. And it looks odd, but keep in mind this does keep going forever, so truly it is going to keep following this path that direction, and it is going to keep following this path this direction, and then it just keeps shading. So keep in mind that it does keep going on forever. So what we're going to look at after this is we're going to start putting this into practice into our real-world applications. We're going to look at some story problems. You have to have a really, really solid understanding of how to graph these boundary lines, because when we start getting to story problems with this, we're going to be graphing sometimes 5, 6, 8 boundary lines. Our goal is to get this shaded region. So if you struggle finding your shaded region inside here, you're going to need to do more practice before you start doing your linear programming models.